Okay, let's do some probability involving the word and the word given. So in example 1, it says from the sample space, we have all the numbers through 10. A single number is selected randomly. Find each probability of the given event. Now, event A is you selected an odd number, like 1, 3, 5, 7, 9. Event B is the selected number is a multiple of 3, like 3, 6, and 9. So for part A, it says, what's the probability of B? So we want it to be a multiple of 3. So we already looked at those, the number 3, the number 6, the number 9. Those are all multiples of 3. So that gives us 3 possibilities out of 10. So the answer to that piece would be 3/10. Now let's look at the next piece. It says the probability it is A and B. It has to meet both requirements. In other words, it has to be an odd number and it has to be a multiple of 3. Both, okay? So let's look at it. Here's our multiples of 3. 3, 6, 9. So how many of those are also odd numbers? Well, 3 is an odd number, 9 is an odd number, 6 is even, so that one doesn't count. So we would have 2 out of 10. And don't forget that reduces to 1/5. So the answer to part B would be 1/5. Now let's look at part C. Part C has a line in it. Let's talk about what that means. This line right here means given. The probability of B given A. That means all you care about, all you're looking at to begin with is the A's, okay? Given it's already an A. So let's go up here and look at A. Select the number as odd. So we're talking about 1, 3, 5, 7, and 9. Those are all our odd numbers. Now what we want to do is find the probability of B, that it is a multiple of 3, given that it's odd. So we only care about these 5. So that's a multiple of 3. That's a multiple of 3. So the answer to this one is going to be 2 out of those 5. The word given means we care about those 5 numbers, and that's it. So let's look at another one. That one would be 2/5. Let's look at the next example. It says, given a family with 2 children, find the probabilities that. Okay, first of all, with 2 children, you can have a boy first, then another boy, a boy first, then a girl first, then a boy, or a girl first, then another girl. That's called the sample set. That's our only choices, okay? So let's read part A. Both are girls given at least one is a girl. Okay, so let's look at this. At least one's a girl means the boy doesn't count. We're talking about boy, girl. We're talking about girl, boy. And we're talking about girl, girl. Those are the only 3 we care about because it says given that at least one is a girl. Now we want the probability that both are girls. Okay, so that happens 1 time out of 3. So the answer to that would be 1/3. Remember, we only care about those 3 after the given. Let's do the next one. So on the next one, it says, both are girls, given that the older child is a girl. Okay, so given that the older child is a girl, let's look at that. That means we have a girl first and then a boy, or we have 2 girls. Okay, that's all we care about. It says given the older one was a girl. Now, both are girls. That happened 1 time out of those 2. So the probability of that one would be 1/2. On the next example, 2 events are called independent events if the knowledge about occurrence of one does not affect the probability of the other, okay? So in this case, we're drawing a single card. It's going to be an independent event. If we were drawing 2 cards and you didn't put one back, okay, then that would not be an independent event. If you have 2 cards and you don't put one back because it affects your draw on the second card. This one's just a single card. It says we have a 52 card deck. The selected card is a face card for part A, and for B, the selected card is black. So it says, part A says, find the probability of B. So the probability it's black. Well, there are 26 black cards out of 52 cards. So that's going to be 1/2. Okay, so now let's look at the second part. This says find the probability of B given A. Okay, so given A, we have to look at A first. Selected card is a face card. Okay, so there are 12 face cards. All right, fix that. So there are 12 face cards. We're only talking about those 12 face cards. Then it says the probability is black. Well, how many of those 12 face cards are black? Well, there's 3 spades and 3 of the other ones. So that gives us 6 out of those 12, which means half of those face cards are black. So the answer to that one would also be 1/2. Determine whether the events are independent. Well, they are going to be independent. One did not affect the other. They could be black, and it still not affect the fact that it's a face card. Okay, when you're only drawing one card, then it really doesn't affect it. Okay, on this one, it says each year, Jaquique Harper adds to her book collection a number of new publications that she believes will be of lasting value and interest. She has categorized each of her 20 acquisitions for 2011 as hardcover or paperback and as fiction or nonfiction. So the number of books of various categories are shown. So out of hardcover, she has 3 fiction, 5 nonfiction, 8 total. Out of paperback, she has 8 fiction, 4 nonfiction, 12 total. So if you look down, she has 11 fictions. She has 9 nonfiction out of her 20 total books. Okay, so if she randomly chooses a book from the 20, find the probability it is hardcover. Well, if you look across here, there are 8 hardcovers out of 20 books. There's 20 total. You would reduce that to 2/5. Then let's do the next one. Okay, the next one says fiction given it's a hardcover. So we only care about those 8 hardcovers. That's it. Okay, fiction given it's a hardcover. Well, there are 3 out of the 8 that are fiction and were hardcovers to begin with. Now let's look at C. Now C is a little different. This one says and. When you're only talking about one event, and means it has to be both. It has to be a hardcover and a fiction. So let's look. Hardcover and a fiction. There's only 3 out of 20 that were both hardcover and fiction. And means something different in a minute. But when you're only talking about one event, then it means it has to be both anytime you see the and.